In this video, I want to go over the Pythagorean identities that are used in trigonometry. It's all based on the Pythagorean Theorem. First, let's go over that. And for that, we're going to need a right triangle, 90 degrees, angle theta. We'll label the sides A, B, and C, where C is the hypotenuse. And we know from the Pythagorean Theorem that a squared plus b squared is equal to c squared. We know that's a given. Now we can rewrite this as b squared plus a squared is equal to c squared, just rearranging the a and b terms. Now if we divide both sides by c squared, what we're going to get is b squared divided by c squared plus a squared over c squared is equal to c squared divided by c squared, which is equal to 1. Okay, we can rearrange this now. So we're going to get b over c quantity squared plus a over c quantity squared. That's equal to 1. And now we know from previous work, and I've got a link in the back of this video to it, that the sine of theta is b over c, and the cosine of theta is equal to a over c. We had that in a previous video, and so using that we can substitute this in here, so we get sine squared of theta plus the cosine squared of theta is equal to 1. And this is for acute angles. And so this is going to be one of our Pythagorean relationships right here. That the sine squared theta plus the cosine squared theta is equal to 1. Now we can derive this a little bit further and make some more observations here. What we're going to use is we're going to use some previous relationships. The tan of theta is equal to the sine of theta divided by the cosine of theta. And we also know that 1 over the cosine of theta is equal to the secant of theta. So, I'm going to continue on the next page on this. So what we know is if we can substitute in this sine squared theta divided by the cosine squared theta plus 1 is equal to 1 over the cosine squared of theta. What we're going to get is we're going to get the tangent squared of theta using this term right here, plus 1, and then 1 over the cosine squared is the secant squared of theta. So here's another relationship that's part of this Pythagorean identity that relates the tan squared theta plus 1 is equal to secant squared theta. Now we can continue to develop the third one, and now we divide each side of the equation. This top equation up here, sine squared theta plus cosine squared theta is equal to 1. Let's divide both of them by sine squared theta. So that's going to be equal to sine squared theta divided by sine squared theta plus cosine squared theta divided by sine squared theta is equal to 1 over sine squared theta. So what this can be written as 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. and that's using some previous relationships. So this is our third Pythagorean relationship right here. 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. And so those are our three Pythagorean identities. I hope you got something out of this and saw how we can manipulate these relationships based on their ratios of the right triangle and gives new relationships that we can use in other places. Thank you for watching.